Okay, so we'll start, I think 3 to 4 minutes after this. Okay. Am I audible? Hello.
Oh, okay, sir.
Yes, let the others join.
Okay, sir.
Okay, I think some more people are joining, so 1 more minute we'll wait and start. Okay.
Okay, sir.
So my screen is visible, right?
Yes, sir.
Okay, so now let us start the session. So welcome to the week 11 of the NPTEL course, live interactive session on electrical measurement and electronic instruments. And as you know, I will be your TA for this session. So this week we will be solving some numericals on Schmitt trigger and oscillator circuits, right? But before that, do you have any doubts? Because last week many of you were absent, so any doubts from last week and previous to that week or this week, this current week? You are facing any doubts? You must be facing doubts. There must be many doubts. Can I hear some of the doubts?
सर पिछले बार में एक क्वेश्चन था जिसमें सर बोल रहा था मैक्सिमम करंट मेजर करता है, तो वो उसमें थोड़ा सा डाउट था सर। एक क्वेश्चन था।
कौन सा क्वेश्चन है वो? मैक्सिमम करंट कौन से, मतलब ऐसे?
हाँ, असाइनमेंट का था सर।
Okay, okay. Let me open that. But such kind of problems I must have solved. Have you seen the recorded session? Because last week you were not there.
नो सर।
So you should see the recorded sessions there or to help you, na? Because such kind of problems must have been solved. Let me see. Okay. What was the problem?
अदर सेशन ये अटेंड किए थे सर।
Okay.
लेकिन क्लियर नहीं हो पाया था।
उसमें नहीं हो पाया, तो देखता हूँ मैं।
मैं 2 सेशन अटेंड किया था सर, लेकिन वो क्लियर नहीं हो पाया, इसलिए थोड़ा सा।
ओके ओके ओके, मैं और एक बार देख लेता हूँ. Let me see what are the questions first. That was question number, which one?
क्वेश्चन नंबर एग्जैक्ट तो याद नहीं है सर। उसमें आरएमएस वैल्यू निकालना था और वो मतलब पीएमसी मैक्सिमम करंट मेजर करेगा, ऐसे कुछ क्वेश्चन था सर।
PMMC का था ना?
यस सर, यस
I
सर।
think you must be talking about this question, where you have a, मतलब 2 क्वेश्चन है मेरे पास, 4 क्वेश्चन है ऐसे, मतलब पिछले वीक. तो वो कौन से आप बता रहे हैं? मतलब मे बी आई कैन शो यू.
उसमें 2 क्वेश्चन था सर, वो
हाँ.
सेकंड लास्ट होगा हमको लग रहा है उसमें।
सेकंड लास्ट वगैरह है ना, उसका 2 सब पार्ट्स जो था.
दो सब पार्ट था सर क्वेश्चन में, उसमें दो क्वेश्चन था।
ओके ओके, आई
एक
गॉट
में
इट।
आरएमएस निकालना था और लास्ट वाला में आरएमएस।
करेक्ट करेक्ट। So what you are talking about maybe is this problem. So I am drawing the problem. Okay. I hope this is the problem, right?
यस सर।
ये आपका हो गया पीएमएमसी मीटर।
यस सर।
And you have these supplies VCC and minus VCC. And क्वेश्चन में पूछा गया था दो सब पार्ट्स। तो ये हो गया क्वेश्चन फ्रॉम प्रीवियस वीक, और ये एक्चुअली है वीक आपका 10, क्वेश्चन नंबर 6 है।
10 का है सर ये।
ठीक है,
सेकेंड लास्ट वाला डाउट था सर, वो मैक्सिमम करंट वाला।
हाँ वही मैक्सिमम करंट का आपका एस्टिमेट जो है, इसमें मैक्सिमम करंट का तो पूछा नहीं, मैक्सिमम इनपुट वोल्टेज का पूछा है, नॉट करंट। यही था ना क्वेश्चन?
यस सर।
हाँ, तो एस्टिमेट इसमें तो करंट का नहीं है, एस्टिमेट मैक्सिमम इनपुट वोल्टेज पूछा है, आरएमएस वैल्यू ऑफ इनपुट वोल्टेज और मैक्सिमम वैल्यू ऑफ इनपुट वोल्टेज।
सेकेंड लास्ट में जो आरएमएस वैल्यू निकालने बोला था, जो जिसमें ये मैक्सिमम करंट मेजर कर रहा है, तो उसमें हमको डाउट है कि ये मैक्सिमम करंट मेजर कर रहा है कि ये एवरेज वैल्यू मतलब मेजर कर रहा है सर, ये मेरे को थोड़ा सा डाउट है।
क्वेश्चन लाइन ऑफ द क्वेश्चन, क्वेश्चन में क्या मतलब यहाँ पे जो क्वेश्चन आप बता रहे हैं उसमें दो सब पार्ट्स है, एक है एस्टिमेट द आरएमएस वैल्यू ऑफ द इनपुट वोल्टेज और एक है एस्टिमेट द आरएमएस वैल्यू ऑफ द
यस
इनपुट।
सर।
Yes, estimate the RMS value of the input voltage was the one part, and then other part was the estimate the maximum input voltage that can be measured before op-amp saturation is created. So which one was the question? Can you read out the question?
इसमें सर जैसे मैक्सिमम करंट मेजर कर रहा है, ये क्वेश्चन में दिया हुआ था, ठीक है।
नहीं वो
और हम
छोड़िए,
लोगों को
क्वेश्चन
निकाल
में क्या दिया हुआ था छोड़िए, आप क्वेश्चन में कहीं भी बोला नहीं कि मैक्सिमम करंट मेजर कर रहा है, कहीं पर भी लिखा नहीं है। क्वेश्चन में ये डायग्राम दिया हुआ है और दो सब पार्ट दिया हुआ है।
यस सर।
कि इन द अबव इंटरनल इन द अबव सर्किट इसमें दिया हुआ है कि इसका 600 ओम रेजिस्टेंस है एंड फॉरवर्ड ड्रॉप वी फॉरवर्ड इज 0.7, ठीक है।
यस सर।
So they have asked two subparts. I hope you are confused. Let me write down the parts. Estimate RMS value in volts of V in if PMMC reads 12 milliamps. A हो गया एक part. Now the next part
Yes,
is
sir.
maximum input voltage.
Yes, sir.
RMS that can be measured before saturation. These were the two parts.
Yes, sir.
So in these two parts, what you have to actually determine, आपके पास एक unknown voltage है, ठीक है? You have a unknown input voltage. ये AC voltage है.
Yes, sir.
And you have this diode followed by a PMMC and this op-amp circuit. तो इसमें आपको क्या मेजर करना है? एस्टिमेट द आरएमएस वैल्यू ऑफ इनपुट वोल्टेज, आरएमएस वैल्यू पूछ रहा है, ठीक है?
Yes, sir.
इफ तो कहाँ से ये बताना है, क्योंकि ये तो पता नहीं, तो बट यू नो द पीएमएमसी रीडिंग, एंड पीएमएमसी क्या रीड करता है?
एवरेज वैल्यू सर,
ऑलवेज एवरेज वैल्यू। तो PMMC एक्चुअली एवरेज वैल्यू ही रीड कर रहा है, लेकिन आपको वो देख के और कंसीडरिंग द डायोड ड्रॉप यू हैव टू डिटरमाइन द RMS वैल्यू ऑफ द इनपुट सिग्नल। तो अगर आप मेरे पास आप ये बोलिए अगर मेरे पास एक फुल वेव रेक्टिफाइड साइन वेव है, फुल वेव रेक्टिफाइड sine wave, then what can I say about of its maximum amplitude as Vm? Then what is its RMS and average value? Can you tell me? And same thing, obviously this is 0 pi 2 pi and all those things. Obviously, and same चीज अगर मैं हाफ वेव रेक्टिफाइड के लिए भी ड्रॉ करता हूँ, तो this is a half wave rectified version ना, क्योंकि you are blocking the negative half cycle, the positive lobes are appearing. So what can you tell about the RMS and average value? पहले ये बताइए। So this is a question for you. Kindly tell me what is the RMS and average value? Yes. You can take time. Some take 1 minute and think and then answer. Yes. Hello. Am I audible? Hello.
yes sir. हाफ
हाँ
वेव
तो
का
ये
होगा सर VM/पाई होगा सर, और फुल वेव का एवरेज वैल्यू होगा 2 × VM/पाई।
ओके, तो ये हो गया 2 VM, सॉरी दिस इज नॉट 2, दिस इज हाफ वेव ना, दिस इज VM/पाई एंड दिस इज 2 VM/पाई। ये तो हो गया। चलिए RMS बताइए।
फुल वेव का होगा सर VM/√2 सर।
करेक्ट। तो आप एक चीज नोटिस कीजिए, अगर आपका इनपुट वोल्टेज ऐसे दिखता है और या फिर ऐसे दिखता है ऑफ सेम स्ट्रेंथ, तो फिर आपका कोई भी डिफरेंस नहीं आएगा RMS वैल्यू में, क्योंकि यू आर ऑलरेडी स्क्वायरिंग इट। तो सेम VM/√2। एंड इसका
बाई 2 होगा सर, VM/2।
करेक्ट। ये बाई 2 क्यों आया?
एक साइकिल 0 हो रहा है इसमें सर।
हाँ, लेकिन बाई 2 क्यों? बाई नॉट बाई √2? So it is correct. You are telling correct. Vm/2 only. तो ये पूरा एरिया एक्चुअली हम क्या करते हैं आरएमएस में? स्क्वायर देन मीन देन रूट ना. सो ये जो स्क्वायर का एरिया है, स्क्वायर का एरिया आपका आधा हो गया, हाफ हो गया ना पहले पहले के कंपैरिजन में. एक साइकिल में स्क्वायर का एरिया आपका आधा हो गया. तो जो भी हो रहा था उससे आधा हो रहा था, लेकिन फिर से ऊपर में रूट भी है, तो ये पूरा एरिया आपका आधा हो गया, फिर रूट है. तो ये जो √2 आ रहा था, इसके और एक 1/√2 आएगा, तो Vm/2 होगा. ठीक है, मतलब जस्ट फॉर योर रेफरेंस हाउ इट इज हैपनिंग. तो फिर अभी यहाँ क्या करेंगे? ये चारों चीज आपको पता लग गया. अभी बोलिए, अभी तो इजी हो गया. पीएमएमसी क्या मेजर करता है? ये करंट जो आपको दिया हुआ है, दूसरे कलर से दिखाता हूँ. दिस इज गिवन सम इंफॉर्मेशन ऑफ 12 मिलियन. ठीक है, तो ये करंट ऐसे फ्लो हो सकता है या ऐसे फ्लो हो सकता है? तो कैसे फ्लो होगा? अंदर तो जा नहीं सकता ओपैम्प का, डायोड के थ्रू जा सकता है ओनली पॉजिटिव में. करेक्ट? ये जो करंट
यस
है,
सर.
बट द पीएमएमसी कैन मेजर ओनली द हाफ वेव रेक्टिफाइड वर्जन. व्हाई? बोलिए. करंट कुछ ऐसा हो जाएगा, क्योंकि डायोड विल ब्लॉक द नेगेटिव हाफ साइकिल ऑफ द करंट. ये तो जीरो हो गया ना आपका, वर्चुअल शॉर्ट है.
यस सर.
तो ये बाई ये 0 डिवाइडेड बाई R इज द करंट, एक्चुअल करंट. सो इफ आई राइट प्रॉपरली, I actual AC is what? P in divided by 20, which looks something like this. But the diode will block this, because this current has to flow, na?
यस सर.
Huh. What I'm telling is, this already you know. Any doubt up to this?
नो सर.
Then what can you do to find the PMMC current?
ये सर्किट में करंट निकालेंगे सर. ये सर्किट
तो आपको पूछा क्या गया है? आपको पूछा क्या गया है?
आरएमएस वैल्यू.
Estimate RMS value of input voltage. Correct? So what I'm telling, this voltage you already know, right? This voltage drop I can tell. So maybe ठीक है. तो ये तो आपका हो गया डायोड प्लस पीएमएमसी, क्योंकि आपका 0 वोल्ट इधर ही आ रहा है ना. 0 वोल्ट इज हियर. तो करंट तो इधर नहीं जाएगा, लेकिन वोल्टेज आ रहा है इधर ना. तो वोल्टेज ड्रॉप कितना हो गया? मे बी नेक्स्ट पेज आई कैन. सो आपका वोल्टेज ड्रॉप कितना हो गया? V in minus 0. is nothing but V in, है ना? क्लियर? तो ये कितना होगा?
यस सर।
I into 20. But what is I? Measured by PMMC. Which is average, ना? So average voltage equal to जितना भी करंट दिया हुआ है 12 मिली एम्पेयर टाइम्स 20. पर आप कोई भी आप में से एक चीज मेरे को बता सकते हैं कि हम ऐसे क्यों कर रहे हैं, मतलब ये करंट कहाँ से आ रहा है? Can anyone tell me why we are taking this current as the PMMC current? बात समझ में आ रहा है मैं क्या बोल रहा हूँ? ये जो करंट है ना, ये तो हम ऐसे कंसीडर कर रहे हैं ना कि पीएमएमसी के थ्रू जा रहा है, तभी तो हाफ वेव रेक्टिफाइड करंट सबको दिखेगा ना. एंड दिस करंट ओनली वी आर कंसीडरिंग बिकॉज पीएमएमसी रीडिंग इज गिवन हियर, एवरेज ऑब्वियसली, एंड दैट टाइम्स 20 वी आर डूइंग. लेकिन यहाँ तो 0 वोल्ट है. Any idea? बात समझ में आ रहा है कि पीएमएमसी का जो करंट, ये जो करंट फ्लो हो रहा है, दिस करंट forced by the supply, this current is going through the diode and getting only the positive half lobe and going to the PMMC. But what I am telling, this has a volt, this is a voltage. Now this is 0 volt. This current should go to some ground, na? So why it is going to the PMMC? बताइए. आपको क्या लगता है करंट कौन सा पाथ फॉलो करेगा?
अब तो सर डायोड वाला ही करना चाहिए सर, इधर तो.
हाँ, क्यों?
बट हाई रेजिस्टेंस होगा ना सर डायोड में.
तो हाई रेजिस्टेंस वाला पाथ थोड़ी ना करंट फ्लो फॉलो करता है, करंट तो लो रेजिस्टेंस वाला पाथ फॉलो करता है. तो ये यहाँ तो 0 वोल्ट बैठा है, 0 वोल्ट.
सर 0 वोल्ट है, लेकिन उसका इनपुट इम्पीडेंस बहुत ज्यादा होता है ना, ये.
Correct, but you are telling exactly its input impedance is very high. Correct, but what I am telling here the potential is 0 volt, right? So what can you comment about the potential here? Simple, its potential will be much lower than 0 volt, na?
नेगेटिव होना होगा ना सर.
हाँ, तो इसीलिए करंट इधर virtually potential becomes 0. Why virtually potential becomes 0? Due to the infinite gain and input impedance being very high. That's why virtual short works due to the static characteristics of the op-amp. But the current will be forcefully driven to this side. So that's why we are always talking about the PMMC current being this current. So I hope now that was a great doubt. Some of you also asked in the previous sessions. So I think this current 12 milliampere is, you understand now where it is appearing from. Now, if I know this current, which is I, whatever be the value, times 20, this will give me what? This input voltage, because I just now told you V in is nothing but this average, all in average form. Because we only have the average value of current, so we'll get the average value of voltage. Clear?
Yes, sir.
So what is it? 240 millivolt. And you already know that average voltage is nothing but what? Vm by pi. तो Vm क्या होता है? √2 V in RMS. कह सकते हैं ना ऐसे?
Yes.
तो इसको आप एक काम करिए, इसके साथ इक्वेट कर दीजिए. Then what you get? √2 V in. But I need the maximum value or RMS. Oh, I need the RMS value. Okay. तो 240 कहाँ से आया? 12 मिली इंटू 20. अभी निकालिए V in RMS कितना होगा? निकालिए. Yes, please tell me the answer. ये मिली है, ठीक है? Hello, am I audible?
Yes, sir.
Please tell me the answer. ये तो सिंपल है, ये इसमें क्या करना है? बाई √2 करिए, ठीक है? तो दिस इज अमोंग आई थिंक 0.5. नहीं आ रहा है? And the answer also given is same in your assignment. आया सबका या फिर नहीं आया? इससे ये निकालना है ना. Kindly give me some feedback so that I can understand. Hello.
Yes, sir.
So now we come to the second part of this problem, question number 6, part B of the week 10 assignment as a doubt problem. And now we see that in the second part what is being asked is to calculate the maximum input voltage RMS before saturation. RMS value just before saturation. So first I will give you some time to think about the problem and then we will solve the problem. Okay. So just consider that the diode drop, forward drop is 0.7 volt and this is the voltage impressed across the PMMC, and this is plus Vsat, which is nothing but plus VCC just before saturation. Okay.
And what is plus VCC? It is 12 volts. It is given in the problem, and minus VCC is minus 12 volts. So now in this condition, just before hitting the saturation, you are being asked to calculate the maximum value of input voltage that can be measured by the PMMC. So this is the PMMC meter. So just think about this problem for some time. So just analyzing the current direction, we can just see that the current is flowing from here to here, and then since the op-amp input impedance is ideally infinite, no current can go into the op-amp, so all the current is diverted here through the diode and then to the meter. So this is the current path. So now the voltage applied across the PMMC can be just, we can see the Kirchhoff's voltage law, and since this is 0 volts, we can start from here. Then we can see that VPMMC, you can just see the mod, and the reading will be 15 minus 12 minus 0.7 in volts. 12 minus 0.7 volts. And this will be the average PMMC reading. Now our PMMC is 600 ohms, implies the current through PMMC, and this is the average current, but the maximum possible average current just before hitting the saturation. So this current came due to some input voltage value, so that input voltage value is desired to be determined. Now IPMMC max average value is nothing but 12 minus 0.7 divided by 600 amp. So this is the value. Now corresponding to this maximum possible average value for a particular input voltage that needs to be determined in this problem is being asked. So V in, coming from input side, V in minus 0 divided by 20 is the input current. Now if we average it, we'll get the average input current. The average input current is nothing but this. So now we can write V in average is nothing but 12 minus 0.7 by 600 into 20. So V in average is Vm by pi. Because corresponds to half wave rectified form, because we are calculating it from the PMMC current, and PMMC is having this kind of current waveform, because the positive half is blocked by the diode. So that current's average value is, we are having this, the average value. So this times 20 will give you the voltage, but in the half wave form. So what is the average strength? Vm by pi. But V RMS is required for the input signal. Input signal is looking like this. So for this signal, we need the average value, RMS value. So Vm by pi is the average value of the half wave rectified form, which is nothing but this, and we need VRMS, which is Vm by root 2, and Vm is what? 12 minus 0.7 by 600 into 20 pi. This is Vm by root 2. So this is VRMS. So kindly calculate what it is coming. So it is coming around 0.83 volts. So this is the answer.
Okay, now so let us move on to the numericals on Schmitt trigger and oscillator circuits. So do this problem, then we can again come back and discuss. First, try this problem. First two parts are very easy. 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 Then you can see the next parts.
फर्स्ट वाला तो सी होगा ना सर?
फर्स्ट वाला किसके लिए पूछा? वेव फॉर्म ऑफ V1.
यस सर.
V1 पूछा है, तो ठीक है. तो ये कैसे आपने पता कि ये होगा? क्योंकि यू एज्यूम दैट देयर एग्जिस्ट सम डिफरेंशियल वोल्टेज जो इसको टॉगल कराएगा स्क्वायर वेव के फॉर्म में. और स्क्वायर वेव अगर इनपुट जाता है टू अ इंटीग्रेटर सर्किट, so it becomes a ramp. So here V1 becomes a ramp kind of thing and it becomes triangular. तो ये तो करेक्ट है. V2 भी आपने बता दिया. V2 is square. तो C, D, E and F. Tell me. Yes, done. So that was easy, right? This is plus VCC, this is minus VCC. Then what is it asked? V1 पूछा है ना, V2 तो आप बता ही देंगे ऐसे ही. V2 बोलिए क्या होगा? 2 into 12, 24 volts. V1 बताइए. इस वाले स्टेज का गेन क्या है? Am I audible? Hello? Are you with me?
Yes, sir.
Yes. So what I am asking, what is the gain of this stage? So that is a linear gain, right? So V1 by V2 I can write is nothing but 3 by 5. So V1 is 3 by 5 of V2. Or V2 if it is 12 volts, then V1 is something like this. But I need 2 V1 because peak to peak it is asked. So V1 peak to peak is 6 by 5 times V2. So do it, what is it coming? 72 by 5. 14.4. This is 14.4 volts. Now calculate the time periods. Okay. So time period, how will you calculate? You just use this formula. Current is nothing but C dV dt. From this parameter, you will calculate the time. Okay. So time you have to calculate in millisecond. both for V1 and V2. Okay. So tell me when this condition will be true. I told you. So this is 0, this is 0. Because virtual short will not work. So we cannot write it. But we can draft the condition for which V2 will hit the saturation point. So let us assume this as some voltage Vx. So what we can write? V2 minus Vx, this current, right? By R3 will be nothing but Vx minus V1 by R2.
6 ohm.
Correct? This is always valid, right? So can you write the equation for V2 and Vx? Because whenever this Vx will be, we will determine the condition, what will be the condition on Vx. But if Vx is greater than 0, then your and Vx is less than 0, then the negative toggling will happen. So that is why we are trying to determine the condition. So R2, R3 we already know. R2 and R3 are same. Sorry, R2 is what? 3 and R3 is 5. So from here, kindly develop a relation between V2 and Vx.
Yes. X equal to होगा सर V1 into R1. Sorry sir. V1 into 5 kilo ohm plus V2 into 3 kilo ohm by 8 kilo ohm, sir.
Okay. So let us put it and see. Okay. So we can just remove this. So V2 minus Vx by 5 is Vx minus V1 by D, or else we can write 3V2 minus 3Vx equal to 5Vx minus 5V1, or we can write 8Vx equal to 3V2 plus 5V1, or X equal to 3 by 8 V2 plus 5 by 8 V1. So from here you can develop conditions, just as we discussed previously, that when the Vx is greater than 0, your V output will hit minus VCC to plus VCC, and Vx less than 0, then V output will go from plus VCC to minus VCC. This is well proven. Now impose the condition on this and try to determine what will be the values of V2 and V1, the threshold points I am telling. because obviously will be governed by V1. So determine what will be V1 for which V2 will toggle, because V2 is the output, right? So let me do 3 by 8 times V2 plus 5 by 8 times V1. First, let us do greater than 0. When you do greater than 0, see the initial one. It was minus VCC. V2 was minus VCC, so plug minus VCC here. So 3 by 8 minus VCC, which is minus 12, plus 5 by 8 V1 greater than 0. So V1 क्या आ जाएगा condition? V1 should be greater than 36 by 5. और अगर लेस देन 0 करते हैं तो यहाँ पे प्लस 12 लेना पड़ेगा. 3 by 8 into plus 12 plus 5 by 8 into V1 is less than 0. तो उसमें भी आपका कंडीशन 36 by 5 ही आएगा, minus 36 by 5. So V1 less than minus 36 by 5, which is nothing but 7.2. Minus 7.2 और ये plus 7.2 है, ठीक है. तो ये जैसे ही V1 क्रॉस करेगा 7.2 को तो टॉगलिंग होगा, और जैसे ये फिर माइनस 7.2 को हिट करेगा फिर नेगेटिव टॉगलिंग होगा. तो दैट इज हाउ इट इज गेटिंग रीसेट्स. तो इतना तो पता है कि V1 जब यहाँ पे 7.2 को क्रॉस करेगा तब V1 जब 7.2 को क्रॉस करेगा तब क्या होगा? V2 will toggle from प्लस VCC टू माइनस VCC. तो ये जो डायग्राम आपने लिखा, ये डायग्राम कुछ ऐसे शिफ्टेड होगा, ठीक है. क्यों शिफ्टेड होगा? क्योंकि ये जो टॉगल कंडीशन है ना वो गवर्न करेगा कि कब आपका शिफ्ट होगा. तो प्लस और ये भी चेंज होगा. तो V1 जैसी ग्रेटर देन 7.2 होगा या 7.2 को भी हिट करेगा, then the positive peak will touch. It will go to the positive peak. And जैसे ही वो minus 7.2 को टच करेगा, then it will go back to the negative one. Like this it will work. So this is how the waveform should look. Correct? तो अगर ऊपर ही रहता तो ये टॉगलिंग नहीं पॉसिबल होता, बिकॉज एवरीथिंग इज म्यूचुअली कनेक्टेड ना. वो फीडबैक आ रहा है यहाँ से V2 का. That condition should be satisfied. So this is how it is working. Now knowing this information, can you tell me what will be this time? Because what we need, this time period we need na. Let me take T rise, T fall. So T fall and T rise total will give you T time period T. So you can, since it is symmetric, you can calculate only one and the other will follow 2 times of it. So what is the voltage coming across the capacitor? This virtual short will work because this is not working as a Smith trigger. So in stage 1, virtual short will work because this is a negative feedback, but this is a positive feedback. So here it will not work, but here it will work. So voltage across capacitor is V1. right? This voltage. VC we can also write. Now what is the change in voltage across capacitor? Because we need the change in voltage, right? Delta V by delta T. C delta V delta T. This is I. Yes, I, can you tell me? In any part, in one part you tell me. V2 is appearing here. So V2 is this one, 12. But 12 is the voltage. 12 minus 0 by 2 kilo is the current. And C is how much? 500 micro. And delta V magnitude between these two this time, only this time you tell me. It is how much? 15. And divided by time. But we need 2 times of this time. So this is T rise, I can tell. So T is 2 times T rise. But let us calculate T rise only. 500 micro into 15 into 2K divided by 12. Tell me what is it coming? Then you tell me net 2 times T rise, you tell me. हो गया? Done?
Yes, sir.
How much coming?
5, sir.
How much?
5.
5. No. Do correctly. Micro है ना ये, माइक्रो और किलो है. आपको मिली में निकालना है, मिली सेकेंड.
ये तो है सर.
तो आप माइक्रो और किलो को मल्टीप्लाई करते हैं तो मिली तो आता है. और फिर अंदर वाला ये होगा 500 इंटू 15 इंटू 2/12. कितना आ रहा है? 1250 मिली सेकेंड आ रहा है ना. फिर आप 2 टाइम्स इसको करेंगे तो 2500 मिली सेकेंड आ जाएगा. ठीक है, करेक्ट?
Right, sir. 2. Yes.
So 2500 is same time period for this as well as this, correct? So that you can please be careful. Now next one you take, next one you solve. This is a simple 555 problem. With a SR latch. So set and reset pins are there. Accordingly, you can tap the feedback, just like the working of 555. You have the voltage divider here. Conditionally, this switch is on or off to reset the capacitor voltage and reset the conditions here. So just like the working of a 555 timer based circuit. This is an oscillator circuit, right? Conditionally, the switch is turning on and turning off, as you have seen in the lecture also. So try this problem. So this is, I can tell 3 volts. This is again 6 volts. And this is 9 volts. Yes, any answers? Hello.
Yes, sir.
So tell me VC variation range. So within these two limits, right? Of the this node and this node, whatever is the impressed voltage, between these only this VC will toggle. So it is nothing but VCC by 3 to 2 VCC by 3. Because VC will rise first. When VC starts rising, then what will happen? This reset pin will be enabled. Then it will open. And this will again charge. Right? So VC greater than 3 volts, what will happen? This reset pin will be enabled, right? Getting my point? So this will still remain 0 and R will become 1. So this will be 0. So this will be open. So VC will further rise. But V out is low. So VC is increasing and beyond, greater than 3 volt and beyond. So VC rising, but VR is V out is 0. So low, right? One answer you got. So V out is low. Now VC is still rising. And once it hits the 6 volt point and tries to shoot above, so then this will be set to 1. And this will be 1 hence. And hence VC is more. Right? So this will be R equal to 0 as VC rises. So this will be 0. Sorry, this will be 1 because R is 0 and S is 1. So this will be 1. And then capacitor will again, voltage will fall. So VC cannot go beyond 2 VCC by 3 and go less than VCC by 3 once the mode of operation is set. So this is the variation range. So off time, on time and frequency are being asked. So you know T off, T on, and T is nothing and frequency is nothing but 1 by T, which is nothing but 1 by T on plus 1 by T off. So your T on, T off, all values you know already. What is it? T of T on, T of is R1 plus R2 into capacitor value into ln 2. Then after this T on value also we know R2 into C into ln2. These all are derived already. And hence 1 by T on plus T
Yes,
off
sir.
we will do and determine frequency. So try, this is a direct problem actually. So tell me frequency, on time and off time. On time, off time in seconds, frequency in hertz. tell me what is coming. Yes, what is it coming?
T of equal to 0.779, sir.
Okay. And T on and T off? Hey, frequency is not 0.77. Do correctly?
T of equal to, sir.
हाँ तो T off कितना आ रहा है? T off 0.77
0.
seconds.
Yes, sir.
And T on?
T on आ रहा है सर 0.433.
0.433 correct. And frequency? इन दोनों का सम करके रेसिप्रोकल करी.
.8, sir. Hertz.
ठीक है, अभी इसको ट्राई कीजिए, ये वाला प्रॉब्लम को. प्रॉब्लम दिख रहा है? प्रॉब्लम इज विजिबल ऑन योर स्क्रीन, राइट?
Yes, sir.
So idea is, I think you know that once this voltage becomes more than 0.7 volt, so then the diode gets forward biased, right? And it is grounded. So this arrangement is done by this battery is connected, na? So this is done to pull the voltage to negative value for a short duration. So this problem is already, I think, this arrangement is already discussed in the lecture to how to pull the voltage to the negative value. And accordingly from that, this problem is actually derived. So if you see the feedback fraction, there is nothing but 4 by 4 plus 4, right? 0.5. So these two resistors will actually decide what fraction. By controlling these two resistors, you can also change the pulse width. And obviously this is a Schmitt trigger arrangement, this part. And the pulse width formula I am writing for you. Once you determine this, you can directly go to the, let me call this beta. So pulse width will be RC ln V0 plus V forward, because some drop is there, so we add the drop, divided by 1 minus beta times V0. Beta is from here. You tell me what will be the pulse width in seconds. So beta we calculated to be 0.5. You plug in beta here and tell me VF you consider to be 0.7. V out you consider to be plus 12 volts. And calculate what is. So for derivation, please refer to the lecture, okay? This will be in the monostable multivibrator form lecture, right? Yes. So what is it coming? So R is nothing but 5 kilo and C is 1 millifarad. So what is it coming? Can you tell me the answer? Hello. Yes, hello. Am I audible? Hello.
Yes, sir.
So tell me, what is it coming?
Ninanbe 467.36. 99.6.
3.749, right? So this will be the answer. So ensure you do all this kilo and milli correctly, right? And V naught is obviously 12 volts and VF is 0.7. So this was the problem. This was also a direct problem of the multi-vibrator. So we have one final problem. So this is the problem. So kindly try. This is also a Schmitt trigger based arrangement, right? Positive feedback is there. So calculate for given time, for calculating time period also always you need to calculate the upper and lower threshold points. So if you calculate, so what is the upper threshold point when this is greater than this voltage, right? You calculate this voltage 4 by 4 plus 4 and V naught you take to be 12 volts. 12 into 4 by 8, 6 volts, right? So obviously LTP will be minus 6 just by using the symmetry. And then time period. Time period you calculate 2 times of T. And for this also I am giving you the formula. So 2 times RC ln V0 minus LTP by V0 minus UTP. Same using just the like the 555 proof. Why this term is coming? You can see the 555 timer lecture and you will get to know why this is coming. So time, you tell me what is the time coming? P0 you can take to be 12 and obviously R equal to 5 kilo ohm and C you can use to be 1 millifarad. So this is 1 millifarad. So what is it coming in seconds? Tell me. Yes, somebody please calculate. It is ln, okay? Base
10.98. 10.98.
Okay. Yes, so these kind of problems are actually will be there. And you think about why this came, okay? is I max times 20. This problem, the second part, na, you actually try and update me in the group, the reason, okay? Then I will re-explain, okay?
Okay, sir.
So you can just solve, try once from your end, and then I will give you the complete solution. Why is it coming so, okay?
Okay, sir.
Okay. Thank you. You can just end the session now.
Thank you, sir. Thank you, sir.
Thank you.